Hi guys, so today we're going to look at adding and subtracting rationals. So this is going to be very similar to multiplying and dividing, but we have to remember in order to add or subtract fractions that we need to get a common denominator. So we're going to just review how to add and subtract fractions with a common denominator. So on this first one, my common denominator would be 35. So I'm going to multiply top and bottom by 5. On the second one, I would need to multiply the top and the bottom by 7. And then once you have that same denominator, you keep the denominator, and then you subtract or add the numbers at the top. And then if you can simplify, you do. In this case, we can't, so we're just going to leave it. Same thing on the next one. Now, one thing to keep in mind, typically you learned how to find the least common denominator. Now, there are many denominators that will work, but the least common denominator will keep this simple. What you need to make sure of is if you don't use the least common denominator, you simplify at the end. Okay, and that's going to be important for today. So for this one, my least common denominator is actually going to be 36. So to get 36, I would multiply the left fraction by 3. I would multiply the right fraction by 2. And then I add straight across the top, and I keep the denominator the same. All right, so we're going to follow the same rules for today. All right, so the very first one, it's actually nicer because it gives us the right denominator already. But what we need to be careful about is how we're subtracting. So I'm doing 3 minus that whole quantity. Okay, and since the denominator is the same, I keep that at the bottom. And now I can subtract. So this becomes 3 minus, so I can change that to plus, a negative, and a positive. Again, both of those need to get that minus on it. So this is going to be a negative 3x plus 7 over x squared. We're also going to list our excluded values, and on this one, x is not equal to 0. All right, so let's look at B. So this one's going to be a little harder to find the denominator for. What you're going to want to do for these to find your denominator is to factor. Okay, so if I factor the left, I get this. If I factor the right, I have this. And the tops won't factor. So now I can see my common denominator. My common denominator is going to be 2x minus 1 and x minus 3. That's going to give me every factor that I have at the bottoms. Okay, so now I need to figure out what these fractions are missing. Okay, so let's look at the left fraction. In order to get that common denominator, my left fraction is missing the x minus 3. So the left fraction is going to get multiplied by x minus 3 on the top and the bottom. On the bottom, that gives me the denominator. Okay, on the top, I would actually multiply that out. So that's going to be x squared minus x minus 6. Then let's look at the right fraction. So the right fraction is just missing the 2. So I'm going to multiply the top and the bottom by 2. Now remember, I'm multiplying everything there by 2. So I am now subtracting 2 times both of those values. And these are all over the same denominator. All right, so now let's simplify. So it's minus, so that becomes plus, and change our signs. So I get x squared plus 3x minus 4 over that common denominator. And now if I look, the top here can actually factor. So I'm going to factor the top. And if you look now, we have a factor that cancels out. And what's going to cancel out is the x minus 1. Now we need to make sure that that 1 is going to be one of those excluded values. Okay, we cannot let x be 1 because, again, it's making the denominator equal 0. So x is not equal to 1. We also know that x is not going to equal 3 because, again, that makes the denominator equal 0. And on this is as far as you can simplify. If you want to distribute, you can rewrite it, but this, basically, if you leave it as x plus 4 over 2, x minus 3, you are fine. If you want to distribute, you get the same thing. All right, I'm going to go back to that first one real quick and just double check, make sure we remember this. I cannot cancel out those x's. Okay, remember, in order to cancel it out, it has to be something that's a factor that we can cancel. And in this case, both of those do not have an x, so we cannot cancel that out. All right, so let's look at some more examples. This next one, if you feel pretty comfortable, I want you to pause the video and try this one on your own. But I'm going to go ahead and work this one out. So I factor the bottom. All right, and then we look and see what our common denominator needs to be. So my common denominator is going to be x minus 4, x plus 3, and then I also need to multiply it by 12 because those are all of my factors. So I look at the left function. The left function is just missing the 12. So I multiply the top and the bottom by 12. So that gives me 12x. I look at the right side. The right side is missing the x plus 3. So I multiply the top and the bottom by x plus 3. And now all I have to do is combine like terms. And I am done. All right, so the last one, this is an example where getting the least common denominator is going to be really helpful. So I'm going to go ahead and factor the bottom of the right fraction. So 3x would come out. So if you look, my right fraction has 9x squared. My left fraction has 9x squared. My right fraction has 3x times x plus 1. So my least common denominator here is actually going to be 9x squared times x plus 1. That is the smallest denominator that's going to be the easiest for me to get. Because if I try and multiply the right fraction and the right fraction by 3x and x plus 1, it's going to give me a really large denominator that's hard to work with. This denominator I can still get by just making a simple multiplication. The left fraction only needs to get multiplied by x plus 1. The right fraction, all it needs that 9x squared, well 3x times 3x, sorry about that, 3x times 3x is going to give you that 9x squared. So that's all I have to multiply this one by. So on the left then, that would be 7x plus 7. On the right, this would be 3x squared. And then at this point, there's no like terms I can really combine. If you want to reorder it so it's in standard form, you can. And just make sure it doesn't factor. This one doesn't, because there's nothing that multiplies to 21 that adds up to 7, so we're not going to be able to factor this one. And then again on this one, x is not going to equal -1, and x is not going to equal 0. All right. So there's two other things we're going to look at. One of these actually we talked about briefly when we looked at graphing, but I did want to show this to you guys just because it's in your book in the same section. So what we can do is, now that we're comfortable with our operations, we can rewrite our functions. Some of our rational functions can be rewritten to look like transformations from the parent. So what we can do to rewrite it in this form, we're actually going to use division. Okay, so 2x minus 3 over x plus 1 is 2x minus 3 divided by x minus 1. So this is a question we can use synthetic division for. So I'm going to do synthetic division. I bring down my first number, I multiply, I add down the column. Now if you remember our answer, we start 1 degree less and we write the remainder as a fraction over the divisor. So that's what I'm going to do for this one. This would be 2 plus -1 over x minus 1, which if I want I can rewrite as -1 over x minus 1 plus 2. And that is in that transformation form. Okay, we would know this would go to the right one, this would be shifted up 2, and it also would be a reflection. All right, if I wanted to graph it, again, you could, but let's look at our asymptotes. We know the vertical asymptote's at 1. We also know from here, by dividing leading coefficients, we know that our horizontal asymptote would be 2. Same thing in this transformation form, we went up 2. All right, you also can work backwards now using what you know about common denominators. So let's go the opposite way. In order to add 2, I would need to multiply top and bottom by x minus 1. So now I can combine those, and I end up with 2x minus 3, which is what I had in my original problem. So we can go back and forth between these two forms now, depending on which one you think is easier. All right, then the last thing we're going to look at looks more complicated than it is, but these are complex fractions where we have just multiple operations combined. All right, so again, what this really does is we're looking at addition and subtraction with our multiplication and division. So we're going to start with this first one. Okay, the easiest way to do this is to break it into smaller parts. So we're going to start just by looking at the top here. Okay, x over 6 minus x over 3. So what I'm going to do is I'm going to combine those two fractions together with a common denominator. So in order to do that, my common denominator is going to be 6. So this fraction would get multiplied by 2 top and bottom. So this would be x minus 2x over 6. All right, now I'm going to look at the bottom of my fraction. I can combine my bottom two fractions together with a common denominator of 10. I would multiply each of those by 2. So that gives me 2x minus 7 over 10. So now we looked at this yesterday. Just remember that big division bar, okay, that's all that is division. So I'm going to rewrite this horizontally as a division problem. So this is x minus 2x over 6 divided by 2x minus 7 over 10. And when I divide fractions, I flip the second and I multiply. Whoops, I didn't flip it. So this is 10 over 2x minus 7. Now again, at this step we had no excluded values. At this step we do, so x is not going to equal 7 over 2. But let's finish this up. I can simplify my 6 and my 10. Multiply across the top. Whoops, let me actually simplify this top right here. This is a negative x. I can just combine my like terms on that one. And then I end up with negative 5x over 6x minus 21. And again, remember, canceling rules. You cannot cancel those x's, okay? We cannot do that, so don't try that. All right, the last one we're going to look at kind of combines this all together. This is actually a format that you probably will see coming up in some of your future math classes. But we're going to solve this the same way. Okay, I'm going to look at just the top of this fraction. And I am going to combine these two fractions together with a common denominator. Okay, that common denominator is going to be x times x plus h. All right, so each of those factors independently, I need to multiply the other one by. So my left fraction gets multiplied by x. My right fraction gets multiplied by x plus h. So that leaves me with x minus x plus h over that common denominator. And then my whole fraction is still divided by h. All right, so I'm going to go ahead and simplify this. So this is going to simplify. X minus x goes away. So I am left with just negative h. I am dividing by h at the bottom. Okay, so I'm going to go ahead and write it the same way for now. I'm going to rewrite it horizontally now. Okay, if I am dividing by h, then I am multiplying by 1 over h. My h's cancel, and I'm left with negative 1 over x times x plus h. All right, so that's all we have for adding and subtracting rational numbers. Again, make sure you get a common factor, find a common denominator, you keep that denominator the same, and whatever you multiply the top of the fraction by, you're going to multiply the bottom of the fraction as well.